Hello, everyone. My name is Daniel Young. I'm the public health representative that has the privilege to present the radiation safety topic to new incoming radiographic technologists each year. Some of this may be a review for you all, but it is important that we rehash these topics so that everyone is on the same page and protected from potential hazards. I hope you all enjoy. This is sort of a rough outline of important topics, in my opinion, that I'm hoping to cover today. We will define ionizing radiation, look into some commonly talked about cancers and their risk, the role of PPE or personal protective equipment and how it plays in on this risk, and the SIR CIRSE joint guideline that was recently published about pregnancy and fertility risk in the setting of occupational radiation exposure. So for starters, what is ionizing radiation? I'm sure some of you have probably covered this in your studies, but I felt like this was a great starting point for us today. In theory, there are two main categories of radiation: particulate or particles, and wave or electromagnetic radiation. The idea of particulate radiation is that you actually have charged particles that are able to interact indirectly or directly with the atom's electrons. This interaction has the potential to change the charge of the substance the particles are interacting with, forming ions, hence the term ionizing radiation. I listed some examples here like alpha and beta particles. And then there's electromagnetic or wave radiation. This is literally a wave of photons that are uncharged that go on to interact with other matter. Again, I've listed some examples, and for us today, the most important is X-rays. These are the rays you will likely encounter daily, whether it be through plain film X-rays, CT scans, or fluoroscopy. All of these modalities use X-rays, and it is important because of the line just below the example list. These rays are high-frequency electromagnetic waves, and these types of electromagnetic waves are ionizing. This brings us to sort of the meat and potatoes of today's discussion. What's it have to do with you, right? So the ionizing radiation has the potential to form radioactive isotopes. There are a ton of examples of this occurring naturally in our daily lives, but the true concern is the last point on this slide. These isotopes can damage DNA and cause cancer. For a population like yourselves, who are potentially exposed to these rays multiple times a day for an entire career's lifetime, this is important to consider so that you all can have long, safe careers. So, how much of a risk are you at with this exposure? I decided to pick the three most commonly published or talked about cancers in the field, and I'll go through them in these next few slides. First up is thyroid cancer. Many of you probably already are aware of the thyroid shield you all wear, hopefully, during scans requiring you to be in the room. The study I chose looked at roughly 90,000 of your colleagues from the years 1983 to 2013, and I sent them questionnaires to fill out in regards to thyroid cancer. They found almost 500 thyroid cancer cases in this cohort, and after analysis, they found no association between those exposed to low to moderate dose ionizing radiation and thyroid cancer. Emphasis on the low to moderate dose, though, which would require you to all wear a thyroid shield to protect yourselves from large amounts of radiation during your daily work schedule. Next up is breast cancer. This was a very similar cohort study done looking at your colleagues from 1983 to 2008 that included almost 84,000 female technologists in 2008. You can see the large number of both primary breast cancers and deaths that they found in this cohort. And their data supported that the higher radiation dose exposures were linked to breast cancer incidence. The last point was important for me to include as well, because they were able to show that this incidence was much more prevalent in women born before 1930, who also reported higher annual doses of radiation. This serves as another early peek into the importance of appropriate protective equipment that we will talk about later. Lastly, I chose intracranial neoplasms, aka brain tumors. Again, they conducted a similar study to the previous two studies talked about, where they used a large cohort of 84,000 female and 27,000 male radiologic technologists from the years 1983 to 2012. They found 193 technologists died of malignant brain tumors, and they were able to incorporate cumulative brain dose into the equation as well when looking at these participants. What they found was that there was no association between radiation dose exposure with malignant brain tumors, and that neither sex was particularly more susceptible. So, no need to worry about this alleged brain tumor risk. This makes sense clinically too if you think about it, considering a skull or brain protection cap of some sort isn't required in your line of work. This data showed that it wasn't necessary. Interestingly, they attributed to the increased incidence reported in other studies to being due to an increase in healthcare access compared to the general population. Basically because all of you work in a hospital setting and could be screened very easily. With all of that being said, the thyroid cancer and breast cancer risk is real. Those studies showed that the risk was dependent on the dose exposure, which brings us to this important point of PPE, or personal protective equipment. As you can see on this slide, thyroid shields cut the exposure dose by 2.5 times, and lead aprons soaked up 90% of the scatter radiation when in the room. These are incredibly important in driving down your risk, so do not take them for granted. I also listed some guidelines because not everyone knows that the equipment you wear isn't good for life. It actually deteriorates over time, and the EPA actually recommends that you have an annual evaluation of the PPE. This is to ensure the lead equivalent material is thick enough to protect you. It is also important to ensure the equipment fits correctly, so take the time to ensure you're being appropriately protected by doing an annual, and I repeat, annual inspection. The last point is more of a point brought to my attention by being around the hospital. The talk of fertility risk and whether or not you can be pregnant and still work without risking damage to the fetus has been brought up numerous times. The points are valid, seeing as we try to avoid all costs scanning someone who is pregnant. These questions, many believe, have been a part of the huge gender gap in both radiology and radiography. Only 21% of radiologists in the US are female, and 75% of radiographers are female. This is not an institution-specific issue either, seeing as the SIR, or Society of Interventional Radiology, and ACR, the American College of Radiology, have taken the time to investigate and work towards solutions to diversify the workforce. One of the largest efforts on this front that I could find was a joint guideline put out by the SIR and the CIRSE, which is the Cardiovascular and Interventional Radiological Society of Europe. These questions on fertility and fetus malformations risk were directly addressed by these guidelines. We don't have the time to walk through the huge document they put out, but I summarized it as best I could on this slide. I encourage you all to look into it yourselves, and definitely reach out to me with any questions regarding it. What they found was that with today's PPE and safety measures provided by governmental organizations, there was no association with either of these concerns when the radiation dose was below the regulatory requirement dose. Again, this would require you all to wear your PPE appropriately and ensure that you are protected as best as possible. These are important for you all to know as well, so that as you move forward in your careers, 1, you are aware of the protection provided to you by your equipment and other safety measures, and 2, you can be an advocate to diversify your workforce. So, in summary, do not neglect your safety equipment. The risk of some cancers, thyroid and breast discussed here today, are real and should not be taken lightly. Recognize whether or not you need to be in the room for the procedure or scan, and take the time to ensure your equipment 1, fits you, and 2, is up to date on its protective qualities. Remember that annual exam of your equipment. Also, take it upon yourself to help diversify the field of radiology and be an advocate for safe practice in your department. There is never a case of someone not needing appropriate protection. Lastly, keep yourselves up to date on current guidelines so that you ensure the safety of yourself and your coworkers. This was a lot of information in a short period of time, so I also wanted to include my contact information. If any of you have any questions over topics discussed today, or about topics maybe not covered, feel free to reach out to me and I'll address them as best I can. I hope you all enjoyed this talk, and I wish all of you have a long, safe career in radiology. These are the resources used today, and a copy can be provided to those of you interested in learning more. Thank you for your time.